Thank you. That's touching. So let's dive right in. So we looked Wednesday for the very first time at how to write a real program using a real programming language. And by real, I just mean more traditional, a little less user-friendly than Scratch, but ultimately much more powerful, because with a language like C and later PHP and JavaScript, can you command a computer to really do some sophisticated things without some of the limitations or challenges you might have run into in Scratch, where you might have just found it hard to express yourself sometimes because a puzzle piece just didn't exist or you didn't know where to find it. So we introduced C, and we introduced the CS50 appliance. And just to kind of get things flowing, what in sort of easy to understand terms is the CS50 appliance? Someone? Yeah. Good. So it's an operating system inside of a window on your computer. And so it allows us to create the illusion that all of you are running the same operating system. It happens to be called Fedora, which is a version of Linux. But what that means is that you'll all have a uniform desktop open in a window on your computer, no matter whether you have a Mac or Windows or any type of other machine. So once you get this thing installed, and the PDFs for Problem Set 1, which will be posted later today on the course's website, will walk you through the process of installing that. Once you have this environment on your computer, we opened up a very simple text editor last time, akin to Notepad or TextEdit or even Microsoft Word, but much, much, much simpler than that. And so if I go to Menu in the CS50 appliance, and I go to Programming, and I go to Gedit here, or notice at the bottom, just like in macOS and Windows, I can click an icon that's just right there, always at the bottom. I get this text editor like this. And in the top here, I have a blinking prompt and a big white space where I can start writing code. And at the bottom, I had what we called a terminal window. And this is just another program that happens to be embedded inside of Gedit. And it just facilitates the process of doing what? Running your program, and before that, compiling your program. Because in Linux, and also in Mac OS, and even in Windows, if you have the right tools, the first programs we'll write will assume a command line environment, whereby you don't so much double-click icons and choose things from menus. Rather, when you want to run a program, you type its name at a prompt. And that program might be GCC, which was the name of the compiler we used. That program might be called hello, which you yourself wrote. But ultimately, you can run it in this window. Now, as you acclimate, and the problem set will mention this as well, this gets very limiting. You've got 90% of the screen for your code and like 10% for this terminal window. Well, realize also under the CS50 menu, you can go to Menu, Programming, and then Terminal, and then you can actually get a full screen version of this very same tool. And it's black and white instead of white and black, but the program is exactly the same. And then just like a Mac or a Windows computer, you can just alternate with these icons at the bottom between whatever program you want to use. So just realize you have options, especially if you find this interface limited. Now later in the term, we'll transition to more sophisticated tools, but for now, the intention very deliberately is to keep things simple, so we can focus on the ideas and the code and not so much on the intricacies of stupid new programs. We'll get to more sophisticated things before long. So how do you actually go about writing a program? Well, you open up Gedit, you type in some code, and we'll come back to that in a bit, and then you save it. And you save it with what? Easy question. File extension from last time. So .c. So .c is just the convention where if you're writing a C program, call it .c. In the world of Scratch, your files happen to be called .sb, but your operating system may have even hid that file extension from you. So that's it. It's just a convention. And then once you have a file called hello.c, recall that we could compile it in a couple of ways, but the simplest that we focused on ultimately is just to type make hello. Now, make is not a compiler. It's just like one of these automating tools that just makes it easy to figure out what compiler commands to type so you don't have to think about it or type out something very long and tedious. So make hello will look in your current folder for a file called hello.c. And if it's there, it will translate it into those zeros and ones. Then how did you proceed to run a program called hello? Yeah, so go ahead. Good, /hello, and one tweak. So generally // in this way would be / and the other way would be \. Windows is \, and usually other OSs are / or just /. But exactly, // and then the name of the program, hello, and the / is just a nuisance that specifies it's in this folder because I put it there. It's not some program I installed in some special default location as you would typically do on your own computer. So that's how we might make it. That's how we might run it. Let's actually now do some more interesting things. So to start writing programs in Scratch, you had when green flag clicked, or maybe when I receive, if you were using events. And that block indicated this is the guts of this sprite's program. It's a script. Well, in C, as in a lot of programming languages, main is the equivalent of that. This is the name of the function, the sort of miniature program you need to write with a simple text editor that automatically gets executed, gets run, whenever you type /hello, or whatever your program is called. And so main is really the guts of our program, but main itself, though a function, can call other functions. And recall that on Wednesday we used several times a function called printf. And the F stood for, so just formatted. And that was because with printf, you don't just need to print out verbatim letters and numbers. You can format them in interesting ways. And indeed, problem set 1 will have you leverage printf to print things out like money and the like, so that you don't have to figure out how to insert a decimal point into the output. You can just tell printf, make this look like a decimal point. Make it look like a piece of currency. So printf takes, we call them arguments or parameters, or more generally, inputs. And those were things in between the parentheses. And it could take 0 arguments or 1 argument or 2. You just separated them by commas. But by far the most common thing we saw was just to have a very simple function that in main that used printf and looked a little something like this. So I'm going to go ahead and preemptively go to File, Save. I'm going to just put this on my desktop for now. I'm going to call this hello.c. and hit Enter. And again, the problem set will walk you through this, but even though it looks a little different from Windows and Mac OS, it's the same idea as poking around on your own hard drive. So I'm going to click Save, and now notice the top of the window has changed, indicating that this is indeed hello.c. And silly though this is to dwell on File, Save, the advantage now of this in gedit is because the file ends in .c, gedit's going to do something fancy for us, which is called syntax highlighting. It's going to colorize everything I type in a way that hopefully makes interesting things pop out, rather than leave my code just black and white. So it's not saving the colors in the file, it's just showing them to me as I go. But recall that I began this program with include standard io.h. Then I had int main void. And now notice what gedit's doing too, which is both helpful and annoying depending on your view. It started adding parentheses for me. So as I typed main and then did open parenthesis, it preemptively, because it knows I'm writing C, figured if you opened a paren, you probably want to close it. I'll do that for you. So realize that tools like this try to save you keystrokes, but it can get annoying if you're not expecting it. So just know you can disable this by going to like Edit, Preferences, and poking around. So after this, I had some curly braces. Those two were automatically inserted partly for me. And then I just said something like, oh, hi, world, exclamation point. That was that wasn't the fun. Oh, we have a guest today who finds that funny from college, my college. So let's go ahead and now compile this code. And we have now the following end results. So let me go into my desktop. So notice what I'm doing down here. At the jharvard at appliance prompt, we have, by default, my so-called home directory. This is where all of my files get stored. And now notice that the thing in parentheses that just says tilde, this is just shorthand notation for exactly that. You are in your home directory. But I said a moment ago, I saved this file on my desktop. And so recall from Wednesday that the command to change directory is quite succinctly cd. So by typing cd space desktop and hitting enter, notice my prompt changes, reminding me parenthetically where I am. And if I now type ls for list, I'll see everything that's on my desktop. And indeed, if I minimize this window temporarily, go back to my desktop, there's hello.c. It wasn't there before, but I created it with gedit. So let me maximize this window again. I'll zoom in so that it's more legible. And if I now want to compile my very first program for the second time, what do I type? Make hello. Quite simple as that. So make hello, enter. The fact that no error messages appear, just this one line of output, means make indeed automated the compilation of my program. Notice that if we weren't using make, we would probably have to type a fairly long, fairly annoying encrypted command like this, gcc-ggdb-standard equals c99, and so forth. And we'll explain what all of those mean. But for now, make just simplifies this process. So to now run this program as we proposed before, I can do hello, but not quite, /hello, because it's indeed in my current directory. So now just to make this more clear, this gets, frankly, even in lecture, a little annoying using such a small window. We could do exactly the same thing with this terminal window. I click Terminal. I do cd desktop, I type ls, and I see the same file plus another one. And what's nice about the black and white version of terminal is that it also colorizes files just based on whether they're executable or directories or files. So it's a little more user-friendly. So know that it exists. And similarly, can I now run hello? And if I sort of accidentally try to recompile it, Make realizes you haven't changed your code. I'm not going to waste time regenerating the same zeros and ones. Bam, we are now done with hello. So let's tease this apart and start adding new features. So at the very top here, we have sharp include standard io.h. And just in easy to understand terms, what was that doing for us on Wednesday? Yeah. A little louder? Exactly. That directive includes standard io.h in specifically angled braces is telling the compiler, GCC specifically, and in turn make, that for any functions I might call, see if they exist in a file somewhere on the hard drive called standard io.h, because if I myself didn't write them, odds are someone else did, but I have to tell the compiler in what file they are, we'll call them declared. So we've not used ourselves a .h file. We'll start using those before long. But for now, a .h file, no, just contains the names of functions that other people have written that you yourself can use. Now, fast forward down here, there's this mention of int. And I mentioned briefly on Wednesday the notion of error codes and the like. And so for now, just trust that every program returns a number. And the best number to return is 0. And anything else is usually a problem. So for now, we're just going to take on faith int main, and then in parentheses void. And this is a new word, but take a guess what it means if you say void in between parentheses. Just nothing. It takes no arguments. It takes no input. And that's kind of sensible here, because all this program does, quite foolishly, is just say, oh, hi, world. Oh, hi, world. There's no notion of input, so I can explicitly tell GCC, don't even expect any input into this program. Just do the same thing again and again. So now the curly braces are just a convention. Printf is the name of a function that happens to exist in that file. How do you know? Well, you kind of learn these things in lecture. You read them in documentation. You just know what files to include. And now between quotes, I have what we called an argument or a parameter. And you just have to worry about the minutia of things like the close parenthesis, the semicolon, and more interestingly, this thing. And what did \n represent? So, oh, OK, good. We'll move more quickly now. All right, so new line. And that's the way of telling the computer explicitly, put a line break after these words, because otherwise it's not going to appear. All right, so we can do things that are a little more interesting now, like not